Hi, students. Dr. Madewell here. Let's go ahead and start with our next lecture. Now, for our next lecture, we're going to talk about frequency distributions and skew. So I want you to go ahead and have the skew class handout that's in the weekly module. Go ahead and have that handy. You can either have it on a tablet or on your computer ready to draw on, or a printout. Why do we use frequency distributions? A frequency distribution is going to show us how often each value occurs. It's better than just having the mean, median, mode, and the range. It gives us at each step of the way how many people scored each score. It helps us to identify patterns, clusters, and gaps. And it helps us in a great way when asking for money. We can present information and present people's scores and notify or see if there's a pattern or maybe a big gap in the data. And maybe because of a gap in the data, we're asking for money to help a certain group of people not to have that gap. When we talk about frequency distributions, we often make them into tables. And what we're going to do in our table is we're going to have a column for value labeled as X, a column for frequency with a F, a lowercase f, a column for proportion, and we'll label it with a P, and that's going to be our frequency divided by the number of people in our data set. And then we'll have a final column that says percentage, and our percentage would be our P, or our proportion, times 100. On your notes for this week, I want you to go ahead and make sure that you have all of these listed. And let's go ahead on our next slide, and we're going to make one. On this slide, I am missing a couple of things. First off, we'd want to have a line. Oh my goodness. A line, and I keep running out of room here, to show our headers. Okay, so we have our class interval, our frequency, our proportion, and our percentage. We want to give all of this information, and we also need a line down here according to APA style. But if our first interval is from 90 to 99, that means there were 4 people. From 80 to 89, 6 people. 70 to 79, 5 people. 6, and so on and so forth. And so what we can do is add this up. 4 plus 6 is 10. 10 plus 10, that makes 23. Now, when we talk about our proportion, we need our full data set. And what I'm doing here is showing you, and I hope that you're drawing this out. And what you can do is see that there's a problem here. If we have our note, our n equals 23, p is our proportion, percentage equals percentage. So we want to make sure we tell people what this means. We might even have an f equals frequency. When we give a presentation and we're asking for money, we might put this on a slide. And what we can do is talk about maybe where there's a concern. Now, what's a concern you have? I want you to write in your notes. What I find problematic with this frequency distribution is that we're only accounting for 59% of our data set. Where is everyone else? Okay. Oftentimes that is a big no-no. We don't want to just show the data to our audience that says supports our initiative or our idea. We need the full 100%. If we have missing data, then we need to have zeros in here. Okay, very, very important. Now, let's go ahead and draw over here this as a frequency, let's go ahead and just draw out our data. Now, if we're going to say that our data, maybe our indices start at 0. They're supposed to meet at 0. So if we don't have any data until 50, let's say this is 50 to 59, if we have, let's say this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. If this here is 1, 2, 3 people, okay, from 60 to, if this is, we'll call this 50 to 59. If this is 60 to 69, and we have 3, 4, 5, and 70, we have 5, and 80, we have 6, and 90, we have 4. If we were to connect our data, we don't know what happens here. Does it dive off? Or do we have more data? Is our data more diverse here from 0 to 50? According to this frequency distribution, we don't know. Okay, that's very problematic. And when you are an observer, I want you to call out this to a researcher. Raise your hand high and say, where is the rest of the data? If you are the presenter, do not do this. Okay, make sure you have all your data. Okay, we don't know if the range runs from 50 to 100, we have a whole new ball game. We can just go ahead and put our axis right here. But in this instance, we don't know. Okay, so make sure this is in your notes. Okay, a frequency distribution. If we look here at our percentages, if we just take this and draw it out, we have our standard normal curve of our data as well. And so I really think that's helpful. That's why a frequency distribution is so beneficial. It's just on a different axis. It's our standard normal distribution of our data. Hopefully that was helpful. Now, all right. Now, for this page, I want you to make sure that you download the Skew handout for this week. And what we're going to do, if I can get my annotation to work. Okay, sorry about that. I wanted to make sure my handout was open. The Skew class handout. What I want us to do, I want you to download and open this and have it ready. What we're going to do is we're going to draw on this. And now bear with me as my mouse is not the best as if we were in class. Now, if our data was symmetrical, well, you know what? I'm going to erase that because it looked kind of not so symmetrical. If our data is symmetrical, it means it's going to come up and go down in a steady pace. If our data is mesocurtic, it's going to look the same. It'll be normal. It's not super normal, but I'd like you to practice drawing that. Where symmetrical means that if we were to draw a line in half, oh my goodness, that doesn't even look like it's in half. Oh my goodness. Okay, let me try again. I'm going to try to make where it's just a solid line so I can't mess up. Okay, how does that look? Well, it's kind of leaning, but if our data is normal, that means it's symmetrical or mesocurtic. If we draw a line in the hat and in cutting it in half and we fold the piece of paper over, they would be equivalent on each side. And that's super duper helpful. We want our data to look like that. Now, if we have I'm going to go back to this curvy line. If we have a positive Q, our data is kind of, oh, no. I want squiggly lines here. I'm going to erase that. And I'm going over on time. Now, if we have a positive skew, our data is kind of high and then tails off. And our mode is here farthest beyond our mean. Our negative skew is going to mean that we have low scores until we have this kind of peak here and our mode is way over here. What happens when we have positive or negative skew is that our data is not considered normal. When our data is not considered normal, we have to stop and redesign our study. There's something else going on. Maybe we missed a variable. Maybe we asked questions of people during a tornado or during a power outage, or maybe there was a major national disaster and people were not answering normally. If our data is platykurtic, it comes up and it kind of makes a long base and then it kind of goes back down. If we have a wide plateau or our data is platykurtic, we're okay. If our data is mesokurtic, we're okay. If our data is symmetrical, we're okay. Now, let's look if our data is leptokurtic. If our data is leptokurtic, it comes up and down really fast. And we have a very small bit of variability. If this is the case, what we have is what one would call groupthink, where everybody thinks the same thing. Is that a good thing? Probably not, right? So if our data presents as leptokurtic, we need to stop and redesign. I want to see this on your weekly handout of your drawings. Okay, I'm going to go ahead and clear my drawings and go on to the next page. What do we want when we graph our data? We want our data to be normally distributed. That means we want our mean, median, mode to be in the center of our data. We want our spread to be a nice distance, not too narrow, not too wide. Okay, we don't want it leptokurtic and we don't want it too platykurtic. Okay, kind of think of the story of the three bears. How do we want our data? Just right. Now, we want our sample to present with different viewpoints. If not, we're going to have groupthink, we're going to have leptokurtic data, and we're going to have to restart all over. Doing a research study is time consuming. It takes a lot of work. It's very expensive. We're utilizing all of our resources. We don't want to do it for naught. So if our data is too skewed, what do? We need to redesign our study materials. Maybe we ask the wrong questions. Maybe we ask them in a wrong tone or in a wrong methodology. Okay? Think about it and answer on your handwritten notes. Do you like to talk to a person about the things that you do behind closed doors, or do you want to type it in on a computer? Or are you likely to lie to both? I don't know, right? It's kind of interesting to think about it. I think it's fabulous that maybe we will tell a stranger eye to eye about our deepest, darkest secrets, but maybe we won't tell the people we love. That's why psychology and counseling are so important. If our data is too skewed, we also need to survey a more diverse group of people. Maybe we just focus on all the same people. Okay, we need more diverse people. We also need to think critically and redesign our experiment if our data is too skewed. It's problematic. We need to start over. Okay. This would be great information on your cheat sheet. So what's next? We're going to talk about graphing a little bit more, and we're going to start working on SPSS. So make sure to get it downloaded onto your computer. Thank y'all very much. I appreciate your time. Bye.